Hello, everybody, and welcome to tonight's live broadcast of LambdaSchool's Mini-bootcamp series. My name is Ryan Hamblin. I'm one of the lead instructors here at LambdaSchool. My role is primary to be responsible for a lot of the web development track that you will encounter here at LambdaSchool as part of the 6-month program. So kind of how things work with LambdaSchool. So we have a 6-month program that runs Monday through Friday. The class hours are 9 to 6 p.m. Pacific, and your content for your class is all delivered, online. So you can take the class from wherever you want across the nation, and it's completely remote. And the best part about our 6-month program is that it's completely free up until the point where you graduate the program and then get a job. So this is the first job that I can say that I've ever had in the software development industry where my incentive as an employee is completely aligned with the incentives of our clientele, our personnel that we teach, which is you guys. And that's very, very exciting. That motivation, that incentive being completely aligned, being that we don't actually work as a company unless you succeed in the program, makes things really, really awesome. And I'll be here to answer any questions you have about that later on after we get through some of the stuff that I want to talk about in our mini bootcamp tonight. So for those of you who are joining us, you probably are already part of the LambdaSchool Slack channel. There is a questions channel that I want you to direct your questions to, and Austin is going to moderate your questions tonight. So as soon as you get some questions in there, he'll take note of what's in there. So if you go ahead and jump in that questions channel in the LambdaSchool organization, feel free to ask any questions about any of the content that we're going to go over. I just wanted to make sure that y'all were aware that we are a 6-month-long program, and part of what we're going to be covering tonight and for the rest of the week in this mini bootcamp series is actually going to be carryover for your pre-course work. So as you get accepted into the program and you take our pre-course material, there is a hard cutoff. Either you complete the pre-course material or you don't. And if you do, you will be allowed acceptance into the program. If you don't, then we'll defer you to the next month because our programs start every single month. So about every 4 to 5 weeks, we start a brand new 6-month program that you could be a part of. And the idea of the pre-course material is to get you up to speed on the things that we're going to be presenting on and that you're going to be learning as you go about the LambdaSchool program. Okay, so let's get started. It looks like we have quite a few viewers right now, and that's really exciting. So I wanted to go over a few things just in the web development community in general. Okay, the first thing that I wanted to touch on is this idea of using software to write software. Okay, so I'm going to actually present my screen to everybody. Okay. All right, and right here, what I have installed on my machine is this program called VS Code. So there are many text editors out there. There is Sublime Text. Okay, that's a very, very popular one. It's something that I used for a really long time. It's basically just a program that allows you to write documents to your computer and save these documents so that you can then access those documents later on. Okay, and then use them to write software. So it's pretty cool. So Sublime Text is a really, really good one. Another really good one, and you'll want to go ahead and download one of these and get playing with it. Another really good one is called Atom. Now the reason, not Atomic Blonde, Atom Text Editor. Thank you, Google, for. Okay, so Atom. The reason the one thing that's really, really cool is that this is all open source. Okay, so Atom's really, really fun. It's got a lot of good plugins, and they use this package manager called Atom Package Manager, or APM, and that'll go in and you can use that to install and get shortcuts built into your program or packages that make your life better as a programmer. Another one that I want to go over, and it's my favorite, is VS Code. Now, text editors, IDEs, they're a dime a dozen. So pick one and stick with it. I like to use VS Code, and I'm going to show you why tonight. VS Code is written by Microsoft, but it's one of their first softwares that I know of that's completely cross-platform. So if you see this right here, you can see that this right here shows that we're in the future of software development. I love Visual Studio Code. It is absolutely my favorite. And one of the main reasons is that you can use it in Windows environment, Mac environment, or Linux environment. And all of the packages are completely open source, has a huge community that maintains it. And the best part is it's written in JavaScript, which is my programming language of choice, which a lot of people may think, well, he's crazy for loving JavaScript so much. But that's why I'm here at LambdaSchool, because I got to teach you why I love it so much. Okay, so I program everything on a Mac environment. So, to get up and running, you would just go ahead and click download for Mac, and you have it up and running as soon as you install the application. Now, what it gives us, what text editors give us, is the ability to create robust applications or robust pieces of software by creating files. Because at the end of the day, everything you do that is software is just a single file. Okay, and these files live, anywhere from on our local laptops or desktops or machines, we'll call them, to living up on cloud-based storage software like GitHub. That's basically a version control software on the web that allows you to basically collaborate and create software as a team. So think of it this way. You have a whole bunch of files that you write your code in, and then eventually at the end of the day, they get compiled or built or bundled into one single file that you host somewhere, and that's all software development is. So I have a file on my machine somewhere called Mini-bootcamp.js, and this is the file that I'm going to be writing a bunch of example code and having fun in today. But how can I actually go about creating this file? Well, one way I could do it is I could use a Finder window. So I could just, pull up Finder. I could go and I could say, here at LambdaSchool in the Mini-bootcamp, where is it? Right here. I'm going to create a file, right? And I want that file to be called whatever. And I could save a file there and create it. And you can create a number of files this way. But another way that you could do this is in your text editor. I could go, oh, new file. Cool. I'm going to create a new file. And I'm going to call it new file.js. Okay, so that's what we're going to call this. So I can just hit Command Shift Save to save it as, and then save it as a .js. .js specifies that this document is going to be a JavaScript document. So I want JavaScript to be able to read this document. And JavaScript is a programming language that we do everything in for the first 13 weeks of your course at LambdaSchool, okay? And for all intents and purposes of this bootcamp, it's what we're teaching you, okay? So you can have many different types of documents. You can have documents that are HTML documents. You can have documents that are CSS documents, documents that are Python documents, and everything else in between. But what we're going to be getting at is this idea of .js. So that's one way you could create a document by using your text editor. We'll skip that way. And what I want to show you is actually creating a document by using this thing that we call terminal. Now, I have installed on my machine this program called Hyper. Hyper is a really cool terminal shell. But if you want to use terminal on Mac, all you have to do is search, you just spotlight search for terminal. And what this is it's a way to access our machine without having to use Finder. Let me blow up my screen a little bit so you can kind of see what this does. And what you do is you feed your terminal commands and you tell it stuff that you want it to do. So it's like you feel kind of like a programmer. So if I want to look at everything that's on my desktop, I need to move my directory or change my folder. Directory and folder are synonymous here. So I want to change my directory, my path, where I'm currently located, to my desktop. Cool. So now I could poke and look around all the files that are actually on my desktop. So pretty cool, huh? So if I run that ls command, it's just showing all of the files that exist in that directory. what does this translate to in, normal speak? Basically what I did by running cd is I went to my desktop. Whoops, I clicked on the wrong thing. And now I've got the spinning beach ball. Okay, so let's click at the desktop. And you can see that I listed all of this stuff out in my terminal. So when I said list all the items, basically it's the same thing. I have a bunch of screenshots, a folder called, or directory itself called coffee assets and whatever. So if I want to change directories into coffee assets, I could start doing that right away. Now I can say what's in there. And I can see a bunch of PNG files, .gif files. All these are documents that are saved on my screen. I used these documents to create a presentation that I gave to students at LambdaSchool on the history of coffee. It was pretty fun. So if I want to change back a directory, go back to my desktop, I can just run cd ... And what that does is just says go back one single path. Okay. Now this terminal is free to use. It comes installed on all of your machines. You can use it. I think it's called the command prompt in Windows. In Linux, I've never used a Linux environment, so I'm not certain as to what you would do to access this. But for Mac users, all you have to do is just spotlight search for terminal, which is just using command and shift bar, and you'll be able to find it right away. I have a program on my machine called Hyper that actually makes my terminal a little bit smoother. It just gives me access to terminal. It gives me a little bit more abstraction, a little bit more fun. So I'm going to, you can see right here, I'm listed at the Mini-bootcamp folder directory, okay? So another way to create a document is to use the touch command. So I can say touch, and then I'm just gonna call this new file.js. So now if I go back and if I actually list out the documents that I have in here, I have two documents. I have a new file document, .js document, and a Mini-bootcamp document, okay? So basics of the terminal, very straightforward. The cd command, the touch command are all very, very good things to get to know and use. And these are just prompts. These are programs that your terminal software understands in order to deliver some sort of prompt to your screen. It's just software. So if I wanted to make a directory itself and I wanted to put all of my stuff in that directory, I could simply say make dir mini bootcamp lesson 1. Cool. So we'll make it a long, weird string. So now you can see that I have two files in this Mini-bootcamp directory and a directory in and of itself called Mini-bootcamp lesson 1. So let me cd into Mini-bootcamp lesson 1 so I can change directories, and I'm gonna simply touch our new mini. I could just simply touch lesson.js. Cool. Now, what did this do? You can go back into your Finder and you can check all of this stuff out. So if I go to Mini-bootcamp here, you see that I have created a directory and added a lesson.js file to it. Same thing, with new file. I created these things as if they're new files that I saved. And you can do this all over your machine. I could move into any directory that I want and save files. There's a bunch of commands to copy files over or remove files or change files and things like that. So we won't go into those for now. I just wanted to show you the very most high-level basics of these things. So now I wanted to go over what programming in JavaScript looks like today. Okay, so let's go back to 1997 at a little company called, I believe it was Netscape. And they created this browser, okay? There's probably a lot of you who remember getting on the internet back, in the old modem kind of dial-up days when you screech across the line. You'd have some sort of weird fax machine, you'd be able to access the internet, which was just this connection of all of these these directories that existed all over the place. And then all of a sudden, kind of out of nowhere, it seemed, and I was kind of a younger kid at the time, kind of out of nowhere, it seemed you had the ability to go type in AOL, which is what my family used on an old Mac. We used AOL, like America Online. America is online. And we basically were allowed to have the ability to type in this browser bar at AOL, this weird thing called World Wide Web, like www. So this idea of websites started to get created. Now, websites were software that were hosted that was really clunky. It was really, really hard to program for a really long time. And there came a need to sort of like streamline this process. And it was a project manager or somebody at Netscape who told a man by the name of Brendan Eich to create a programming language that it would allow them to sort of leverage the power of C++, but in an abstracted way within their company. And then their browser that they were creating could read that language and interpret that language. And basically you could manipulate this object called the DOM. Now, I guess the DOM maybe came later. But anyway, I may have my history. This is just sort of like high level of how it all happened. And according to sort of the legend or how the story goes, is that Brendan Eich created JavaScript in like less than 3 weeks. So he threw together this language that was written under the hood in C++ that would allow you to essentially write programs in a much faster, streamlined way for the time. So people started using JavaScript, this language that came out of Netscape, to write these programs. And it became eventually, along the way, over the years, the standard for writing websites, okay? So for programming websites and then allowing people to access those websites, okay? So it became sort of this standard. Now, it's funny that it became a standard while the language itself didn't really have a set version of standards. It's really just kind of whatever Brendan Eich wanted to add to it. And eventually there became, institutions and corporations that started standardizing the language a little bit as it came across the board. And so we have these web browsers now that can read and interpret and understand JavaScript, and we can move into the environment where it comes from. So that was just like a little caveat. I wanted you guys to hear that so that you'd sort of know where we're coming from when we teach JavaScript. So there's multiple environments where JavaScript can be run. And one of those is the Chrome environment or the browser environment. So I wanted to show you, if you were to simply right-click on a web page in Chrome. Now, it's a little bit different in other browsers, but if you were to inspect a web page, you get this thing called the console. This tab right here is the console. Now, one thing that I love about JavaScript is you can write it in any browser. It's available to you anywhere you want it to be. So this is something that's really, really fun, okay? So we can already just start to program JavaScript by just simply clicking on the console button after you inspected the web page. You go and inspect, you can pull up your console, and you can do a lot of other things in here, but we won't worry about it right now. So our browsers read and interpret JavaScript. So because of that, we have it available to us right here in the browser. So I can say something like var name equals Ryan. Cool. So that's really cool. That's awesome. I can actually write JavaScript. So if I log it out, if I just call name, it's going to give me that string back, Ryan, that I gave it. Okay. So this is probably something you're already very used to. You've already done tutorials and looked at things like, how to create a variable. All I did was create an initializer that said name that's going to point to a string of Ryan. Okay. So that's what I've done with this keyword called var. Now, keywords in JavaScript and any other programming language are words that are set aside, that are special for the syntax of that language. Just like the word this and he and she and them and their and there in English, we have words like var that allow us to write programs that JavaScript can read and say, that's a special word, I need to do something with it. We have syntax here. Okay, so you've been very familiar with this. Now var, it has sort of been the way to create a variable and then hold it in memory. and then have access to it. So right here, you can see in the browser, I'm able to write JavaScript just right here in line, which is really, really fun. But what's interesting about var, and since its inception in the early 90s, since it came out with the language, is that it was never given like a specific set of rules. You could do something like name now equals Austin. And while that's fine, that's just reassigning what name points to, I can create a whole new variable named name and point that back to Ryan, and it's going to let me do that. So now if I log out name, it's going to give me back Ryan as opposed to Austin. Now you can see why this would cause problems, because up here, I created a variable named Ryan, or named name, and I pointed it equal to Ryan, and then I created another variable, but I named it same thing, so it just overrode that variable. So to get away from this, in one of the more recent versions of JavaScript called ES6, we get new ways to write that variable command. One of them is let. So let will let us say name equals Ben. Okay, so that's great. Now, if I write name, it's going to say Ben. But if I want to say let name equal Ryan, we're going to get a syntax error. We're going to get an identifier that Ryan has already been declared, or name has already been declared, and it's set to Ben. So you cannot override a let variable. Okay, but what's cool about let is you can say now I want name, since it's equal to Ben, I can still reassign what let name points to. I can just never simply rename a variable, and set it equal to maybe a number, right? I can't do that anymore with the let keyword. So it now has some specific rules. We cannot override what name is, right? But we can reassign it all we want. So that's also a problem, because maybe I have something in my code that I don't want to be reassigned. So we have another keyword out there for assigning an identifier called const. This is short for constants, or constant. So that means it's constantly going to be pointing to the same thing. Now, if you're coming from another programming language, const will behave a little bit differently than you want it to. Something you can do with const is say const name equals, well, this is actually probably not going to let us do this. Yeah, so because let was still in our program. So let me actually do a hard refresh and get rid of our program that we had in here and say const name equals Brian. And there we go. Now we have a pointer. We have an identifier at name. We can reference name at will. So it's pretty fun, right? The same type of thing. But now let's say that we want to be able to reassign this. Because I used const, I'm not allowed to do that anymore. Okay, so const is even more strict than let. Okay, so no longer do we have this ability to just override variables willy-nilly. It's pretty awesome. We have a let keyword, a var keyword, and a const keyword. And all three of them are relevant in any program. But for intents and purposes of our school, we want you to live by the rule of thumb that you name all of your variables const until you cannot. And there are going to be situations in where you can't, okay? So you've seen all this done in the Node environment. These are examples of the var, let, and const keyword. I want to move this, or sorry, in the browser environment, I want to move this into the Node environment. So in 2009, somebody came up, an organization came up with the ability to run programs in JavaScript right here in our server. Now, all you saw, as long as you have Node installed on your machine, you can go to nodejs.org and download the latest version of Node. Okay, and you can start writing in what's called a REPL. So the same thing that I was just doing right here in my browser, I now have access to in my terminal. So I can write programs right here just the same exact way that I was. I can say const name equals Ryan. Cool. What is name? So now I have this REPL, which is just like basically it's an acronym, and it's fleeting me what the name of the acronym actually stands for. But I can start writing programs, and it's in a different environment. Okay. So what's cool about this is I now have JavaScript running in the browser, in any web browser that I want. Okay. It's all JavaScript. It all has to be JavaScript. That's what web browsers read. And now I can actually take that same code and that same context and use that programming language JavaScript in the server or in a Node environment. And that's all that Node.js is. We're going to be going over all of that for you in depth here at LambdaSchool as you work your way through the program. So some stuff that's really, really cool about this is that I can run and write an application cross-platform. Now, what that means is I can write my web page, and then I can write where the data gets stored all in JavaScript. And that makes for very, very nice, fun programming, okay? Because it's all one language, all right? So I've kind of tackled a couple of key principles and what's cool about this, but I'm going to go over some things that I like to look at in a Node environment, especially in my text editor. So one of the main reasons that I choose to use VS Code is because of the package manager. There's this package called Quokka. Now, I can basically go to Quokka and download it and install it, but I've already done that on my machine. But what it gives me is the ability to use sort of free syntax highlighting and logging right here in my text editor. I no longer have to do this in the browser or in my terminal shell. So I can, well, let me clear that. Okay, so I can start writing programs that allow me to run over this environment, and I can get instant feedback as to if my program is working. So one thing I can do is say const name equals Ryan, console.log that, and get instant feedback. Okay, I've done a little bit of programming here. It's not very crazy. I've created a variable, set it equal to a constant variable type, and pointed that variable to the name Ryan, okay, to the string Ryan. So, and then I ran this thing called console, which comes in any JavaScript environment you're programming in. You can use this in Node. You can use this in the browser, okay? And then I've called a function log here by saying dot. I've referenced the console object, and I've called .log. Now, I've given log the name Ryan by simply passing this variable around. This is one thing that's really, really cool about functions in JavaScript in general. So you just pass stuff to functions, some sort of input, and you get some sort of output out of them. The output is a printed version of what the name reference points to in the console. And you can see it's pointing it down here at my output, and it's also showing it up right here in the browser. That's what, or right here in the text editor. So this is just my text editor, and I get instant feedback as to whether or not my program is broken or if it's working. So if I were to change this, I could just see, oh, what is name? Name is 1. Cool. So let's go back and let's change it back to Ryan, and let's run our programs. Let's try and break this and see what happens. So now if I want to reassign name, what's going to happen? Well, already Quokka, this package that I have installed with my text editor, is giving me feedback saying, hey, you have a constant variable. You can't reassign it here. Okay, well, let's look at let then. Okay, all right, so let gives me name and the ability to reassign it to Austin. Really, really cool. So now I define my variable, originally set it to Ryan, but I can point to Austin instead. But what happens if I try to do the same thing we were doing? Let name equal Ben. Well, our program's no longer going to run anymore, and we're not going to get too many good. Well, okay, so right here in the terminal, in our output, we're getting a hint. It says identifier name has already been declared. So we can't use name as a declared variable because we're using let. But if I was to change this to var, we would be just fine. Cool. It's going to allow us to do that. That's one of the things that's interesting about var is it's really, really loose. So probably not the best thing to use. Okay. So these features, the variables let, or the keywords let, var, and const, or sorry, let's just say let and const, are new to JavaScript as of 2015. We call this new version ES6. Okay. ES6 is one of the more commonly used versions of JavaScript today, or ECMAScript 6 is what we call it, or they also call it ES6 or ES 2015. Okay. All right, so this is very, very interesting because every single year we're getting a new version of JavaScript. In fact, in July, we just got ES8, which is ES 2017. So we're a year behind the actual version that we're looking at. For our course, because it's most commonly accepted today in terms of standards, we're going to be teaching you the latest and greatest that most everybody is using. And so this is still pretty bleeding edge, as not all browsers support ES6 right away. So to get the support out of ES6 that we want, we use compilers to take JavaScript and turn it into JavaScript. So basically taking JavaScript and using it in the ES5 or the previous version's syntax. But let's build a little program here and let's see if we can make some fun stuff happen with this. Okay, so I'm going to create a few variables and log them to the console, and then we're just going to kind of go through a few things together. Okay. So first thing, I want some sort of variable that's just never going to change, and it's going to be the name. Okay. So, and we're just simply logging this out. Now notice, I just got things, it was breaking because I was trying to reassign name and point it to Austin instead of Ryan. Okay. And let's say that we're going to say age equals, because age is something that we want to be able to update. It's something that we know is going to change because human beings age. We live by the rotation of the Earth around the sun, right? So right now I am 30 rotations around the sun old, okay? So I'm going to say, I'm going to log out to the console a sentence, okay? So I can use the backticks in the top left portion of my keyboard, and this is brand new to ES6 as well, is using this thing called template strings. And I'm going to say, hello, right? My name is, and then I can reference the variable name, Ryan. Now, I have no intention of ever changing my name from Ryan. So that's why I used const. I do know that as I get older, I'm going to, here in October at the end of the month, I'm going to have to update this to say something different, okay? Because it's going to be pointing to a new version of my age. So that's why I used the let keyword there. So this is a very, very common, like a good use case for all of this, okay? So, and I'm going to say, I am, this is a very formal greeting. Age, years, I'm going to say rotations around the sun old. Cool. So now you can see right here in my browser, or sorry, in my output, Quokka is printing out what this console.log function is giving me. And it's a big long string that says hello, and you know, use this you have to use this $sign if we're using template strings to get the value of name out of and log it to the console that way. And it says I am, you know, age rotations around the sun old. So that's what we're getting right here in the browser. So let's say that the end of the month, end of October hits. Yes, I was born just before Halloween, which is awesome because I got birthday presents and candy for my birthday all the time. And I always had the most killer parties with costumes and everything. Let's say that I said now, let's say that I, you know, let's say a date happens, I made it all the way around the sun, and I can simply just say, well, age equals 31. And that's not a very dynamic program because it's just simply reassigning the variable to a fixed number. So, but what I can do is I can use some operators. Now, JavaScript uses math, just like you have been taught, and uses a lot of algebra. You know, you can basically just do math right there in JavaScript. So I could say, you know, whatever age is now going to be equal to age plus 1. So every year that I make it to this program, age is going to be saved as whatever this is, right? And it's going to say, well, 30, you know, so 30 plus 1 gets me 1 more year. So then that'll be saved to this program. We'll store that in memory. So then the next year, it's going to be 32. And then by the time, you know, another year comes around, it's going to be 31. So very simple math you can do right there in JavaScript, and very complex math as well. If I wanted to say now age equals age minus 1, maybe I Benjamin Buttoned all over the place, and I'm actually not aging anymore. Okay, so but for all intents and purposes, this is something you can do in math. When we create an identifier, okay, a variable, for example, and give it some sort of data, which is just a string or a number here, then you can simply update that variable or that identifier by referencing it and updating it with the equal sign. So now we're saying, well, like age now equals whatever the outcome of the current age and plus 1 is. Now, a simple shorthand way to represent this, which is pretty cool, and JavaScript gives us this ability, is I can just say age equals, this is the same thing as what I just had. Okay, it's saying plus equals 1. So I want to take age and add it and set it to whatever, you know, the age plus 1 will equal. So that's a really cool shorthand. So, and you can do really cool, like fun expressions with this, mathematical expressions, all right? So I could do, you know, well, let's see how old Ryan is in dog years. Okay, so I'm going to make a variable, an identifier called Ryan's age in dog years. Okay, and I'm just going to set that equal to nothing. It's just going to be an identifier that I can use later. So now I can say Ryan's age in dog years equals age times 7. So let me make sure. So and I am okay. So I'm going to change this. I am age human years old, and grab the variable here. Dog years old. So check it out. My age is exactly 210 dog years old. So I now have a program. This is just this is a program. Like I've written this in JavaScript and I have this fun program. I'm going to just break the line here so you can see the whole sentence because it's driving me nuts. I'm going to break it that variable. Okay. Cool. So that's one thing that's really cool about template strings is they allow you to like break your line so you don't have to be. I'm just going to bring this back up. Cool. So now it's a little bit easier for my eyes to read as I keep my screen this zoomed in. Programming on a zoomed in screen is not my favorite thing, but I like to do it for broadcasting. Okay. So now this is really awesome. So I have this really rich JavaScript program, and it can be dynamic. So every single year, I'm going to come in and I'm going to run this age and say now age, plus equals age, plus equals 1, right? And so now it's like every year that I come to this program, that I run this program, it's going to say that I am, it's going to update my age in not only human years, but in dog years. So if I come back, let's say I'm old and gray and this program has sat on my machine and, executed this code over and over again. Just gonna bring this back because it's driving me nuts still. Okay, this looks a little bit better than it was. Cool. All right, that's fun. Cool. Hello, my name is Ryan. I'm 90 human years old and 630 dog years old. So by the time I get to complete my 90th birthday, I'll be a really, really old dog. All right, so really, really cool, right? So I have this ability to just do math right here in my program. So I'm multiplying, I'm adding a single year. Once again, we can shorthand this away. We can take this and we can shorthand everything away here. So I could just say times equals 7. Probably already guessed that. Oh, hold on. That's giving me not a number. So maybe I need another program to be able to do that. So that's probably newer in JavaScript. So I don't have that ability yet. So cool, learned a lesson today. Okay, so now I'm gonna talk to you about some stuff here. So what do we have going on? We have these things called data types, okay? So JavaScript, basically it has a bunch of data types that allow you to represent data in a certain way. Now, if I'm trying to represent text, normally what I want is this data type called a string. I'm just going to comment this out so you understand what I'm pointing at here. So this is a string data type, okay? Now, another data type is what is right here, which you may have guessed it since it looks numerical. This is just a number. And for other programming languages, you call this an integer. But in JavaScript, we just call it and reference it as a number, okay? Another data type in JavaScript is called a Boolean. And that's ubiquitous to a lot of programming languages, but we get it in JavaScript as well. So let's make a variable called let old equal false. Okay, so a Boolean is a true or a false variable, okay? Now I use let here because I know I'm gonna update old based on, some sort of program, okay? So I'm gonna say let old equal false, and that is a type Boolean. Now, one thing that's interesting about JavaScript is it is dynamically typed, meaning I don't need to say something like const string is a name and that points to Ryan. I can just simply represent my data like this. I can identify that Ryan is here, and JavaScript knows that's a string. JavaScript knows this is a number. JavaScript knows this is false. Or this is a Boolean, I'm sorry. Yeah, it does know that it's false, and that, it's a type false of Boolean, okay? All right, so I can actually look at this stuff. I can say something like, I can say, well, I don't know how far I want to go into that, but yeah, that's fine. I can do this. Okay, so strings, numbers, and Booleans are probably the three most common data types you're going to see. There's others out there like objects and arrays, but we won't get to those tonight. Okay, but I wanted you to see these as they are and as they work. So one thing you can do, and don't worry too much about this, but there's this way to compare data in JavaScript, and we use what's called an if statement. And this is going to give us a true or false based on some kind of condition that we go into here. So if I say something like let name, equal Ryan, then I'm going to say console.log, his name is $name. Awesome. Otherwise, it's not going to do it. So if I change this name to Austin, we're not going to hit this console log. This has to be true in order for this thing to hit, okay? So I'm simply showing you this as a way to write conditionals. This is a conditional. This is conditional logic. And we use triple equals, so 3 equal sign, to say that name really does equal the string Ryan, okay? And I can do the same thing for age, but there's this really cool keyword in JavaScript called type of. So if I want to see the type of name and say that's equal to a string, it's going to be true. So name is equal to a string, and then it's actually logging out the name. So we have a block of code in these parentheses here, these curly brackets here, that allows us to run some sort of program. So yes, name does equal a type of string. So name is of type string. So we're going to log this name out to the console. Pretty fun. So I could do the same thing for age. So does age equal a string? Well, no, it doesn't. And so because of that, we need to see if it's a number. Look at that. It is. So type of, you can say type of your identifier is pointing to some sort of data type. And we get those in JavaScript right out of the box. It's just part of the programming language, strings, numbers, and Booleans. So I can do the same thing, and you guessed it, for old, and set that equal to Boolean. And yes, he is old, right? So his name is old. So it's just like his name is false. So that's set to a true or false value. So if something is true in these parentheses, we're going to go into this in further depth tomorrow night, but I just wanted to show you the type system in JavaScript, how it exists today. So we use this thing called type of to look and see what our data identifiers are pointing at. So let's move forward, okay? So that was just a quick, actually I can leave that and I can just simply comment it out, and I'm gonna actually move it to the bottom of the file, whoops. So I can grab this all and just move it to the bottom of the file, because I'm actually going to publish this gist for you later and provide you a link to access this stuff. Okay. Okay, so let's write a program that I'm going to go back to Ryan because Austin probably doesn't want me using his name. No, I'm just kidding. Let's go to a program and let's actually look at this idea of comparisons, and we can go over these strings. So I'm going to do that same identifier, that same comparison, and I'm going to say if age is greater than, so this is just math, so I can use greater than and less than here. Let's say, what is an old age today? 67? Well, 60 is probably closer to senior citizen age. I'm not quite sure the rules, but we'll just go with it. So if age is greater than 60, then I want to change old to true. Old equals true. So reassign that old. So because I am old, I'm going to console.log old. And I'm actually going to change the name of this old variable because I don't like it. I'm going to change it to is old so that it's an evaluation. Okay, so now you can see that because I've set my age greater than 60, it's going to simply change what this was set to. So that's why I used the let here, because I knew it was going to actually update and be pointing to something new. So it was false originally because we're not old when we're first born. So if I change this back to 10, I'm just a young child at that point. So I could say console.log is old. Even here, we haven't hit this condition. Age is greater than 60, but that's false. So that's not true. So it's never going to change the value here. So this is a program. This is me just programming. So all right, so now it's really cool that I have this little program. So what does that allow me to do? Well, I can do mathematical expressions in here, and I can do things like finding the remainder of something, dividing something, multiplying something. So I'm going to say we're going to leave this program, but I'm going to just start doing math, because who doesn't love good old math? And here's the thing: a lot of theory in mathematics and computer science is based, is based around the same principles. In fact, mathematics was used to build what we know as computer science today. Okay, so a lot of how we think and operate as software engineers is very mathematical style thinking. So if you thought you're getting into a career that you need to know, or you don't need to know math, you're wrong. You need to actually know a little bit to get by. You don't need to know crazy stuff, but yes, you need to know some math. So let's say const. Well, I don't want to do that. I want to say let number equal 10. Now I'm going to console.log number. Before I console log it, I'm going to now say that number equals number divided by 10. It's got to be defined. This is what I love about Quokka. You can see like the outcome of our number in our program. We were able to just do division right there. Okay, so division is cool and all. That's fine. You can do it. You can easily use it. But I wanted to show you this idea of using what's called the modulo operator. So modulo is a really cool operator that allows us to get the remainder of a number. So I can say something like number equals number modulo, which is a percent sign, 10. Now, oops. Gotta write my programs correctly. Now, since 10 divided by 10 is 0, and there's no remainder, we get 0. But what if I did 9? Okay, cool. So we can use the modulo operator to basically figure out the remainder of some number that's divided into the number that's given. So far we've gone over in math the fact that you can add. Let's see, I'm going to make these notes up here. So math, you can simply add. I showed you we could subtract because I did that really briefly. Multiply, divide, and now find the modulo operator. So we can find the remainder of some function. So what's cool about this is I can check to see if age is an even number. That's going to be interesting to figure out. So I'm going to say is even. I'm going to change this variable to is even. Okay, This is very commonly used in JavaScript, is like finding the modulo to figure out if something is even, if numbers are even in a concept. Okay, so now let's say that maybe I was born on a leap year and I want to divide it and find a remainder, and if it's like divided by 4 or whatever and there's no remainder, and then, you know, whatever program. But let's say for this program, I'm just checking to see if, you know, my age is even. So if it's even, there's going to be no. So if I say age is divisible by 2, which is an even number, so if I can divide it in half and there's no remainder after that, so that's going to be 0, then look, we're going to set is even to true. Currently it's set to false until it checks this number. So if Ryan's age, if age is divisible by 2 and has no remainder, then it's going to be an even number, right? So just by that logic, we can see is even. I'm going to bring this up. Bring it up even further. There we go. Awesome. So now if I actually update this number to odd, whoops, you can see that it's going to change to false, because what is the operation of this? So if I made a variable and said let new checked if even say equals that, and I use my console.log to log out the result of that thing, you can see that I actually just want to not set it equal to 0 because I don't want a Boolean there. I want to actually see the number. So you can see that if it's even, you know, 11 divided by 2, 2 goes into 11 5 times with the remainder of 1. So we get that 1 left over. And so because of that, it's not an even number, right? But if I go up to 12, it's going to be 0. And so because we're saying if it is equal to 0, then this is going to be an even number every single time, as long as this condition right here matches to true, okay? As long as we get a true value out of that condition, okay? So now you've seen right here in our trusty notes, with math, you've seen the ability to add, minus, multiply, divide, and then use the modulo operator to get some sort of condition to check, okay? So once again, a condition, we're going to be going over this later on through our mini bootcamp, and then even, you know, in the course, and you're going to have to use conditions every single day as a JavaScript programmer. This condition, and this is not something just, you know, singular to JavaScript. This is something in programming all over the place. You have a condition, say, hey, this thing is true, then do something. You know, set this thing to true if it is. Otherwise, we're going to ignore this code on line 13 right here. Okay. So that's just an if statement. Now, we'll get into much more in depth on that later. In fact, it wasn't part of the curriculum to cover tonight, so I gave you a bonus ball. So throw that bonus ball right through the hoop. Okay, so with JavaScript, we have this really cool object that allows us to use math. Like, it basically takes all this stuff and sort of abstracts it away from us, okay? So let's say that I had a number, some sort of const float number equals 3.45, okay? All right. Now, who remembers back in their, you know, arithmetic days when you would actually have to round numbers? It was like all you did in this assignment, you know, like the 4th or 3rd grade, you know, whatever advanced or non-advanced math was for that time, is you would take this number and take it to the, you know, a whole number. Well, JavaScript has this thing called math that allows us to perform operations on it. And you can go to, I'll give you a link in the description of this as soon as it's done uploading to YouTube. I'll give you a description link to the file where you can reference all these things. So if I wanted to say math.round and pass it that number, float number, okay. This is actually going to take this and round it up or down to either 3 or 4, depending on what our float is. And a float is just numbers after a decimal. There's numbers floating after our whole number. We really like whole numbers in JavaScript. So I'm going to say const float number rounded equals, and then perform this operation. So I'm going to pass, round as a function on the math object, okay? So I'm going to pass a float number to that constructor object, and I'm going to say, hey, round the number. And round is just going to take it and either go up or down based on where we're at. Now, we would expect that it's going to round it down because we didn't get over 5. which is kind of the rule of thumb in math. That's just whatever. So if I were to console.log our float number rounded, we're going to see it's going to take it to 3 for us. So we were able to perform an operation on that just by using the math object. Okay. Now that's really, really cool. This is right here, just built into JavaScript. It comes out of the box. But what if I want to force this number to either always be round up or down? So there's 2 other methods we can use. I'm gonna basically take this same program, and then I'm gonna say round it up. So I can say math.ceil, which, oh, I may have spelled that wrong. Ceil, yeah, there it is. Cool, thank you, IntelliSense. Okay, and then I'm gonna console.log that. Okay, now you can see that I took it to, and ceil is short for ceiling. Okay, so we took it to the ceiling of this whole number here and went all the way up. So round is good because you can just get a round number out of that float number that I described here. But you can also say ceil, which will round it up every single time, regardless of what the integer is. Regardless of what your float is, we're going to take it all the way up. So even if we pass this, you know, a 1 after all, I can't even like pronounce the decimal place that we just went to. But if we were just to pass it all those zeros and a 1, it's going to take it all the way up to 4 on our rounded up function. Okay, so I'm going to do the same thing, but now we're going to round down. Okay, so the way to round it down, and I'm going to console log before anything else happens here, is to use another function that's on the math constructor called floor. So ceiling and floor. So think of it as you have, I'm going to use, well, I'm not going to do that. That's fine. So think of it as you have this whole number that represents a building, and you're inside that building. Okay, that whole number is 3, and then you have a big float after it, a big pile of decimal places. Okay, now you give it one position and you call ceil, and it's going to take it to the ceiling of that building and give you the next whole number available, which is 4. Floor will round it down, ceil will round it up, and round will just follow the rules of math. Now if we take this to 7, we're going to get the same type of thing, but just the opposite effect, where we actually get to the ceil, or no, just math.round gives us 4 this time instead of 3, because it followed that mathematical rule. So anything 5 right above 4.9, so I could say 4.0000001 and be just fine, or I could go 4, 99999, and it's still going to round it down. So just like you were taught, in grade school math, that once you get to 5, it's going to round it up. So this round has some program built under it that's going to actually equate that and round it up or down based on where you're at with your float. So that's not all you can do with math. Let's say we had a program and we wanted to find the power of something. So find the exponent of something. So if I say, if I wanted to do this, it'd be pretty easy. So I could say something like, const new number equals 5. Okay, let's play around with this. Let's say const power of 5 equals math.pow. Now what's cool is I have this text editor, VS Code. So because it knows that math is a common, it is a constructor in the JavaScript language, I have the ability to read this file. It's JavaScript. It's giving me some hints as to how I can operate with this. So I can simply pass the power, which is returns the value of, returns the value of a base expression taken to a specified power. So my base is 5, okay? So I'm going to say new number, and then the power that I want to raise it to is 2. So the power, if you remember, the exponent is going to take that and multiply it, okay? So let's say, okay, so now I want to say const, oh, whoops. I just want to console.log. I want to keep everything together here. So, okay. I want to keep everything together so that you can see how these all commonly work. And then make sure that we log them out in order as well. So console.log, our power of 5. Let's see what happens here. Whoa, Okay, so we passed it 5, and we said we wanted to raise it to the power of 2. So that's going to say, take this and multiply this number by itself 2 times. So a really powerful operator right there, right? If you ever needed to find the exponent of something, you just pass it a number, because this is a function. It's going to take 2 arguments. The first argument is the x value, or our base value, and then the number of times we want to multiply it by itself. This would be the same thing as saying, power new number times new number, right away. We could write a program that does that. Or we could just say, hey, new number, times however many times we give it. So if I give this, 3 times, it's going to go 5 times 5 times 5, which is going to be 125. Let's see how many times we can do this. So look, it's taking it and it's representing that number because it's such a big number to the exponent of 24 there. So we're already at a very big number. So even just, multiplying 5 10 times by itself puts us into the millions. So we'll just keep it right there at a very easy to read and understand 3, which is 125. Okay, so those are 4 very, very common math functions. Now I told you I was going to show you a link to where you can do this, and once again I will link this in the notes of the live recorded series tonight. Okay, so I'm just going to show you this thing called MDN, and then we'll wrap it up. MDN is a web, they're Mozilla. Mozilla is a developer network, and it allows you to search for things within the JavaScript specification. So things that are available to you that you need to use. So this resource, this is basically JavaScript documentation right here, teaching you how to use the language. So if I look at the math constructor, we're just going to look right here at this second one given. We can see that there are a bunch of methods that you can use. You can use like a cosine, asin. Yeah, you can use all these things that I haven't used since sophomore year of high school. But right here you can see, oh, math.floor. I'm familiar with that. Ryan showed me that. Okay, so if I look at this documentation, it's going to show me exactly how I can use this. It's going to give you a description. It's going to show you, code examples. It's going to show you how you're going to be able to use it in every situation that you want to use it. And then the more important thing is browser compatibility. This is going to show you in all the major browsers if it's compatible. Okay, so something like this is compatible across every major browser out there. Okay. So this is how you start to read documentation here. You learn about what it is that you're looking at, the syntax for how it operates, and then you can look at a bunch of examples. Okay, so if you look at all of the stuff that math gives us, we can go to that POW, and you can start to see examples of what that's going to give us, right? So look at this. You can easily find the square root of 4 by multiplying by 4. You can basically say, times 0.5. So find the math.pow gives you a square root. So right out of the box, you're going to get the square root of something by using .pow. Now, I believe there's even a function here called square root, and there is. So you can see right here, you can just square root something and find it. And look, once again, you have browser compatibility across the board for all of these math functions. You find sine, cosine, round. We already showed you round, max and min. So those are pretty cool ones as well. So you can feel free to go to this documentation. And I'm just going to store this in my notes so that I can remind myself to keep this in the notes for this. So let me check in with our fearless leader, Austin, and see. We've gone an hour. I want to make sure that we can answer any questions that you may have. I'm probably the most long-winded instructor you'll see and you'll get at LambdaSchool. I talk a lot, and that can be a good or a bad thing. So I'm just going to make sure that we're good to go. So awesome. Okay, so Austin just informed me that he's been answering questions as we go. We can send time. It looks like we're good. So, all right. So I guess we can just call it good there. And I can link to this in the notes, and we can get going. I covered everything that I wanted to cover today, which is good, and I only went 4 minutes over, which is not so good. So if you have any questions, I'm a part of your Slack organization. Feel free to reach out to me. Feel free to reach out to Austin. Feel free to reach out to Ben as well. We're really excited to have you along with us this week, and we're good to go. So let me give you your assignment, what you're going to be working on for the rest of the evening here. It's this. One second. Okay. So all of your assignments are going to be done here on this thing called Replit. You're going to go in, you're going to find an assignment, and you're going to be able to click on that function assignment, and then you can go and write your code right away. Okay. And then you can test it by running the tests over your code. Once these pass, you can submit the assignment. So that's kind of how this works. So everyone's going to need to go in and sign up for this classroom. I'm going to post it. I'll figure out from Austin exactly where. I'll just post it right here in the questions channel that y'all have been a part of. You'll have to sign up for a Replit account, and then we're going to be able to see, as you come in, we'll be able to grab, anything that you need, or, grab, give you feedback on any of the stuff that you have. So please enjoy. We're excited to have you with us, and let us know if you have any questions about Lambda School in general. We'll be around.